All right. Let's see. Yeah, there's some really cool stuff happening around LoRa, the long range Wi-Fi stuff. That's a really cool area to explore a lot further. And it's the thing that JR tried to sell a while back, where you could, if you hooked it up and used your electricity to power it, you would get paid in a tiny fractional amount of Bitcoin. So it's a cool thing. The theremin is really fun. It's a fun way to build a nice little instrument. It's a great one to do because we've got all the components that you need right there in your kit for the board, and we've got tons of those light dependent resistors. And yeah, if you order things from Adafruit, they do come pretty quickly. I would say it's just about as quickly as shipping from Amazon. So if you want to order that, there are a ton of components that are available that are there at MakeHaven. And especially if it's just a few simple things, we probably have some stuff. If you're curious, you can just send me a message. It's very possible that I have it sitting in a bin over in, I have a giant closet right next to me. It's very possible that I have a lot of components in that bin that I'd be happy to share. So there's tons of good options. Any questions before we get to show and tell? Let's see. No, you guys are all quiet. All right. Well, then let's do show and tell. Show and tell my closet. While you guys are sharing, I'll grab a box of stuff and just show you what I've got. There's a ton of weird things. So with that, let's see. Anybody right now? We've got 2 Kates and a Lila and a Ruby. Would anybody like to share first? Lila, you want to go?
I'll go. I'll share my screen.
Excellent.
Figure this out. Own it. I don't know why, but it doesn't. I don't see hold on, show all windows. There we go.
Okay. Got it. Cool. Oh, there we go. Boom.
All right. Where to start? I'll start here.
Ooh.
Ooh, I made this. I'll just go through all the videos I made.
Awesome. Nice little stoplight.
Yeah. And it just printed stop, go, and yield. And what is this one? This is a button. Did that.
That's nice. And a nice keyboard underneath.
Yep. And I made that.
Oh, with the, yeah, that's fun.
And I got the RGB LED going, I think, for this.
Yeah.
Can you go back to that? I made that. Like, it looked like there was a screen, but then it went away quick. Whoop.
Oh, I did. There you go.
It's a 16:2 LCD
Cool.
screen, right?
Yep.
Yeah. And so you can write out text or
turn it light and dark too.
Uh-huh. Yeah, but it's you can write out whatever you want. And so you wrote out hell yes.
Yes. What is this? Is this 3 different LEDs or is it one changing colors?
It looks like you've probably got an RGB connected in there, would be my guess.
It's not a good.
It's hard. There's lots of glare when you're right above them. Oh, that's probably. That might be a better view.
Yeah. Oh, here. I think.
Yeah, and so this is awesome. This is the kind of playing around with little components that's really a good way to get started with Arduino, where you're not focused on a complete project. You're just trying to play with stuff to see how they work back and forth. This is totally valuable electronics play to make sense of what's happening.
Yeah, and then this is the last thing I got going.
Oh, look at that. These like numeric displays actually each one of those is its own separate LED, right?
Right. Yeah.
So learning how to get it to type out all those letters did you use a library or did you
Yeah, I
like,
used a lot of cut and paste when it came to
yeah.
that, honestly. So
And that's totally fine. All that cut and paste, because those are problems that have been solved. There's no reason why you should need to resolve it from scratch.
yeah, yeah. And I'm just learning it too. So
Yeah. Yeah,
all
that's awesome. Yeah, you
right.
definitely hammered through a ton of little projects this week.
Yeah, and then there was one where I wanted to put a few together, but I would have needed a second breadboard. So maybe I'll order a second breadboard. So
Yeah.
I have an
sounds
idea
fun.
for a project. I'll DM you and
Sure.
see if that works. All right, next.
Yeah. Great start. All right. We've got Kate and Ruby and Aaron are all visible. Kate, you want to go?
I was just gonna let you know that I'm gonna go later once the whining dog has been removed from the room. So come back to me.
Yeah, you're good. Okay.
Ruby, you want to go or should I? Okay. Okay. So I had a blast, like super fun. Soldering is cool. I like it. And I made the doohickey that Corey set us up with. I highly recommend making it. It's like you get 5 minutes into it and you're like, okay, like it definitely, the feedback is there to make you feel like you're figuring it out. So if this is a little intimidating, I highly recommend it. I should plug it in. That's how that works. So I have a little battery pack here, right? And it was pretty simple once I used the code, but basically, the light comes on. It's probably very bright, but I can change how frequently it blinks. And like, I don't know if you can see it. It's blinking quite fast right now. I don't know if my webcam is capturing it.
Yeah, there's like there you go. Slow it down and it's.
But you can modulate. This is an encoder. Is what this is?
Yeah, that's the encoder. And so encoders are really like I included it because they're all over the place in your everyday life, but they're really like fairly complicated things because they're two switches that go alternatingly to make it so that it knows how far and in what direction it's spun.
I'm thinking about switching it to the red LED, so like the RGB LED, but just making it red. And then I was thinking about I have to figure out how to do it. I don't know if it's possible, but if I could somehow like hook this up to my home assistant and like leave it off, but if someone was to enter my apartment when I wasn't here, I could get my voice assistant to speak, and then this just to start blinking red, looking like an ominous thing on my fridge. I think that would be kind of comical.
You could go all Mark Rober and like have it be like the voices from Home Alone.
Yeah,
like,
yeah. Like I want to make like I want to prank myself. That's what I want. I want to like, I don't know. Anyway, I had a lot of fun making this. And it's like a practice makes perfect project. I highly recommend it. So thank you, Corey, for making this board.
Aaron, can I ask you a couple of questions since I was there for part of that and like learned a lot by watching you?
Sure.
When you said you want to change the LED, does that mean, would that mean like desoldering?
No, I would just go for the code. I think it would probably be easier to do that. So this LED, what was just blinking, is just straight white. Right? But this one is RGB. So the code that Corey presented is like a color loop. So it's actually really cool that this LED will like do what my expensive LED lights will do, but for like a fraction of the cost. So part of me is like, like maybe I don't need to buy Philips Hue anymore. I probably have the skills necessary to make my own at this point. But like, yeah. So I hope that answers your first question.
Yeah, the other question was, you mentioned a battery pack, and I know we were talking about batteries and the scariness of batteries earlier. Is that something that you purchased, or like what is that?
Gosh, I've had this thing forever. Gosh, maybe like 7 or 8 years. It's like a 20 milliamp hour battery. You can get these for like $20 off of Amazon. I use it to like recharge my phone, You know,
And
things
that
like that when I travel.
I want to you. I'm so glad that you have that, Aaron.
Yeah.
It's the really good example of a battery that solves all the battery problems for you. When that one's dead, it shuts itself off and it won't let it become too dead.
The
If
other
you
thing
buy
that's
like the raw batteries, like a pure LiPo, it won't do any of that management for you and you have to do it. What Aaron's got is perfect. If you want to,
some of these also have like an IQ feature. I don't know if it'll work for smaller electronics, but it can like tell the optimal charging like voltage of like a cell phone, for example. So I don't know if that might translate to like an Arduino, but you know, I figured
yeah,
why not?
IQ charging interestingly works perfectly with Arduino in that it doesn't do anything.
Okay, cool.
Yeah, it's a special chip you put in your cell phone so that it'll say, instead of being charged at 5, I want to be charged at 12 so that I charge in half the time.
I should have phrased that as a question.
Yeah,
rather
no,
than
you're
a
totally right.
statement.
It
Thank you for
completely
that.
works with Arduino, but because it doesn't do anything.
Today I learned.
Yeah. All right. Let's see. Ruby, you want to go?
Oh, also great thing to fidget with at your desk. Just gonna say.
Very nice, Aaron. All right. Ruby or Jamie? Ruby, you were.
Hi. My ear is on. Can you hear me okay? I don't know. It sounds like the ocean right now to me. It's just really loud. Like the furnace is like on my floor, so I can't really do anything about it. Anyways, soldering, that girl is not nice to me. But it's okay. I did one of these this week. This was my first attempt with Corey's help, and it was really like, once you start, you get the hang of it. For me, it was there's definitely a learning curve. And for some reason, the green LED like flickers. Not sure why. I have a feeling it's just gonna go away because everything to me looks perfect. So anyways, I tried again the second time and immediately realized I put the wrong. I put a 330 in a 10K, and you're not supposed to do that. And I successfully managed to take it out with the solder sucker.
That's awesome.
But I don't know if I fried it because it looks kind of gnarly to me. So I kind of was just like, don't risk it, just grab a new one. So I did, and I was pretty much almost done. And then I realized I made the same mistake again. I put a 330 in a 10K slot, and I took it out successfully again, but I don't think I took out all of the solder because I couldn't really see through it. So I was like, you know what? Scrap that. Let's do it again. And this time I did do it all correctly. I made sure to like take my time. And I think my issue is like they look almost identical. Like you really have to pay attention. And that made me overthink. So I'm just like need to just chill, you know. It came out okay. I haven't tried it out yet because I literally just finished it. Like I was just at MakeHaven working on it. And I guess I had a question. My LED pops out a little bit. You see that?
Yeah,
I don't know. Okay.
Totally fine.
Cool. So to me, it should work. I don't really see an issue, but we'll see. This was fun. I had a good time. Yeah.
Yeah, and soldering like that is something that you definitely get better at with practice. So doing it multiple times, you're gonna totally get better just soldering things up. And I would say all those boards that you abandon, you may as well just keep practicing soldering on them, or like stick in components that aren't, you're not trying to even make it work, but you want to look at the solder joint and see if it looks like a Hershey Kiss, if it's got the thing. Desoldering is its own whole skill, so mad props to you for getting things off when you've gotten them on. That's definitely harder. So if you wanted to keep practicing that, that's definitely a good one to do. I helped Jamie get an encoder off of one of these, and it was definitely a 2-person job because you had to heat it up and pull and like get it's not as easy to get them off as it is to get them on.
And it still doesn't work.
Oh,
So
well,
I either got a broken encoder or we fried it, but it was a good lesson.
It's the difficulty of plastic with metal, right? The metal
Yeah.
gets hot and it'll melt the plastic, and then you're kind of stuck.
Something
That'd be cool to take it apart.
Mm-hmm.
I guess I don't know if you answered this question earlier, but I had an easier time like soldering from the front first to make sure like the piece was fully flush or closer to flush versus starting from the back. Is there a difference, or does it matter too much?
It really doesn't matter too much. I like to, for through-hole parts, I like to solder on the back, because then usually if they look crummy, it's the side you solder on. That way my front looks nicer and the back looks crappier. But there's really, that's just for me, there's no real reason. When you get to surface mount, everything has to be on the front. So then you're always soldering on the front. So there's no real reason to go one way or the other. It's whatever you're better at, and it's definitely a bit of an art. So if it works for you, keep doing it.
Cool. All right. Thanks.
Yeah. All right. Jamie or Kate?
I'll go. Unless you want to go, Kate. Okay. I turned the lights off so I could show you this. I played with the register today.
Ooh.
That was something that was on my goal to do, and I even was able to hook up the RGB LED with it. There's a lot of wires here. It's a little hard to see, but what's cool about this, and I have to turn the light on to show, is that I'm literally only using 3 pins for 8 LEDs. And I believe you can, what's it called? Piggyback or daisy chain them so that you're only using 3 pins, and you can hook up multiple, like just like a huge array of LEDs, or I would assume other kinds of outputs and inputs, not just LEDs. So that's pretty exciting to me. So that was something that was like kind of on my to-do list, something I wanted to kind of tackle this week. And I'm still kind of in the middle of understanding it, but hooking it up was probably the hardest part. And then I did this, of course, twice. So maybe it's not working great. Like the pot pin and the encoder aren't working, and neither is the button, strangely. So I'm not sure. Buttons usually work. I've soldered buttons before. The LED, both LEDs work, but nothing appears with the coding. So I don't know if it's the computer or the board I'm using, but I want to still try to get that to work. But it was great practice, and I feel like I refined my soldering skills more this week and desoldering.
Yeah.
So that was cool. And then I tackled the OOP with Corey. So object-oriented programming, and that's pretty cool. I'm gonna have to practice it more and finally understand it. It took a while, but yeah, I got it. And then kind of within that, though, we also played around with the inverted logic of inverted logic LEDs, like the RGB. So it was hard for me to learn those two things simultaneously, but by themselves, that can be done. And I actually started playing with that code today a little bit more. So yeah, so I feel like I accomplished most of my goals for the week and then some. And hooking up all the electronics in my band this week too, which is really terrifying because it's like messing with my home, like my vehicle, and if anything goes wrong, I could kill myself or burn my rig down. So I'm taking that really nice and slow.
Yep, yeah, nice and slow. Yeah, that's a ton of work, and there's plenty of really cool things that happen. The shift register is awesome. They're a great way to just sort of multiply out the pins on an Arduino, so you can control tons and tons of things. And to learn those in partnership with object-oriented programming, objects are really great when you want to have 5 or 8 or 12 of the same thing and you want them to behave the same way. So if you can get those two pieces to work, then it's easier to control a large collection of items. So it's a really good tandem set of things, and the soldering gets better with practice. They're the 3 things that you listed, they're definitely metal and plastic together, right? So in desoldering, we probably baked the pieces, which is why they wouldn't be working, and that it happens. The kits that we bought just had 10 of those components. Otherwise, and there's 10, we need 10 sets. Otherwise, it would have been, here's another one, right?
I mean, it was totally worth frying because to learn how to desolder, like the tricks of that was really valuable to me. And so was just getting another tutorial from you on soldering, like touching the location of the joint. That just basically was a game changer for me because I've been kind of trying not to touch the board, so and I still managed to make those joints happen, but this made it so much more cleaner and easier. So
yeah, the dynamic of how much to touch the board is definitely where the art comes in. Like that's where the skill of practicing soldering is really important, because you need to think about how much heat energy am I adding, and it's partly the time, it's partly how hot is it. It needs to be a certain temperature, but it's not so much like let me calculate it and only touch for 1.26 seconds. It's more of like a feeling for that looks good, and now I think I can pull it off.
Yeah.
So,
yeah. Oh, and yeah, I guess my goal for this coming week would be the AVR programmer, but also just continuing to dive into what I'm already doing here. So it might not be a fancy build project. I don't know if that's okay, but I really want to get the OOP down with the register pin, the shift register, and get that AVR component going, because I think the alarm that I eventually want to build will run a lot cleaner without all the Arduino to it, if that makes sense. That's my theory. I don't know if I'm correct on that, but simplifying it.
We'll have to explore. There's tons of things to look at. Cool. Kate, you got a fun blue light going on. Are you ready?
My glow has changed.
Yeah.
Can you hear me okay?
Yeah.
Okay. I'm in a different room. I've got headphones. Everything is weird. And I have no idea how to, I'm still having a hard time photographing things, which is why I'm trying to show them live, but then the lighting is weird. So while I was waiting for my components to come in for my more Arduino-ish project, which is happening next week, which involves, what is it, like a circuit playground and NeoPixels and all sorts of cool sounding things. I wanted to do something with the light up stuff. So I was playing with the laser and LED tubes, as well as these. So you can see a little bit.
Oh, that's so good.
I have a little glowy heart behind me. This was sort of the and you can't see. So my other hope, let's see if I can pull this off, hence why there's 2 of me, was I was going to try to use my phone. Let's see. Oh, look, you can see all of you. So I don't know. Yeah, you probably can't see that. But stop that video. I'm definitely not made for the DJing of the Zoom world. But so it's an acrylic heart that has, and then I etched Be Kind into the middle of it, which actually makes a really, it's clear acrylic. And so it's a neat shadow behind it. Like it's hard to see because it's just one layer of etching, but it actually makes kind of a neat projection behind it, which was unexpected, or not unexpected. I just didn't think about it, but it worked out cool. And then the other thing I did, let me see with this light, I can figure out how to light this, was I used the EL wire that I had left over from earlier on and did another acrylic etching combining that. So let's see. So this is this down here. And so it's like a wave.
Yeah,
it's like an etched surfing wave kind of thing. So that's the etching. And then this, I made a channel for the EL wire to make sure the surfer silhouette is actually put into the channel there. So I was hoping that that was gonna be done, but I learned a lot, and I think I want to redo a few things on it. But I'm excited to make it even a little more final and a little more permanent. I want to put the background on it and do the etching a little bit different. But I definitely, the biggest thing was hearing Corey, let's see if I can do this. Corey looked at my design and mentioned that I shouldn't have anything, to try to remove the crossing over parts. Initially, this like crossed through here. And so I edited the design a bunch in Inkscape, and that definitely helped. Like that would have been a nightmare if this had actually crossed and I had to try to fit that together. So I appreciated that tip, and we'll see if we can figure that out. How did I make the channel? It's just, it's etching as well on the laser. I spent like 4 hours doing tests of different laser settings. When I finish my blog post, you'll see all the ridiculous pieces I did. So the channel is actually on the standard settings, but I ran it through 5 times. I tried a bunch of different takes on it, and that was the depth I liked best to fit it in there. So you can like kind of just follow it. If it's 1, 2, or 3, you can start to sink it in. And by 5, it was really grabbing it. 7, it goes all the way through. So at least on the settings I had. So that's what I learned there.
Yeah.
Yes. When I get the website posted, I'll let you guys know with the process on that one. It was kind of like I followed that video that was in Foundations, was the start of it, where it was just the tube, this stuff. And then when I didn't have enough tube, I don't know if you can see. So the word back here is breathe. That was my original idea, but I didn't have enough of the LED tube to write the whole word. So I did this just to try it, and then was just playing with this while I was waiting for stuff.
Yeah, there was a ton that you got in there, and you definitely used all those laser skills to maximize the impact of the LED thing, which is really cool to see all of those pieces come together to bring it in. And it's just lovely, right? How those have all come together. I'm so glad that the crossover thing was helpful. It looks really great. There's tons of interesting ways to make it work. Did you end up trying? We talked about how you can do raster with vector lines. Did you give that a shot?
I gave that so many shots, and I really wish I was able to get it to work, because the etching of the heart actually, the heart etching took 30 minutes just to do 1 pass. And I really wanted to do 5 passes with that, and was just like, I can't do any more. So it's just 4, because I knew this one was more of a test. But I would have loved to cut that down. What Corey's talking about is we were trying to basically vector and cheat into an etching. But I tried all the different union and whatever. After Inkscape could not handle it on the middle computer with the laser, but when I moved it on the other one, it would do the processes. It would take a while, but I still never got it. But I definitely want to play with that more, because I think that could be really a nice time saver.
Let's make sure that happens before you cut the breathe thing for real, just because I think it would be a nice time saver. And so what's interesting is that we're talking about using, and I'm seeing if I can pull up, I have a Corel draw file. I can show you all what we're talking about, because raster on the laser is just going back and forth. And so Let me come over here and share my screen to show you what I'm talking about. There's that, and hit share. So this is in Corel. And so here's the state of Connecticut, right? It will ultimately be rastered, but the way that that's achieved is these are a series of vector lines that go back and forth. And so I used a collection of those Boolean tools where you can say, well, I want to have the shape, you know, it was a shape like this word is a shape. And so I used a geometry of the state and then this like cross hatching. Oh, it's very much this shape and this cross hatching. So you just like take this, drag it over here, and then you can do like this thing. And then I've got to, and maybe it's intersect, trim. I think it's intersect. It's this one maybe. And so now I've got just a whole collection of lines where those are all of those cross hatchings for the state of Connecticut. So it's just the pieces where the two overlapped. And it's super helpful because then the laser can go along those lines and effectively raster. It's kind of a dumb use in this case for the state of Connecticut, but Kate's got a design that has lots and lots of empty space. And so the laser is rastering back and forth. If you do this, then the laser just goes and rasters in those areas where you want it to, rather than doing the full back and forth over the entire width and depth.
Corey, I have an example of a photo I did where it's right in front of me where I just did vector, so you can see the difference. Should I show it?
Yeah, just pull it out in front of the.
So this was like a test piece. First I did that raster, you know, with the chain link fence, but then with the landscape I did just the vector, and so you can see it's quite different in like style compared to this.
Mm-hmm.
So I don't know if that's helpful or useful for folks who are doing this.
Yeah, it's totally a neat like hack to use the laser for raster without being in the raster setting. So it's a neat thing to try if you find yourself cutting something with lots of empty space and you want to cut down on the travel time back and forth. So it's a cool process. Let's see. And then we've got Ada and Anna. Do either of you have anything that you want to share? Just offering because you're here.
No, it's the same story for me this week as last week.
Yeah, you're good. That's fine.
I just realized my camera was blocked. Sorry.
You're good.
I just obviously I just got back to where I usually am. So I'm kind of like quarantining a bit until I get 2 consecutive negative COVID tests. But I went shopping where I was to this like really tiny electronics shop that didn't really know what to do with my questions. But I got like LEDs.
Oh, how fun.
And then I asked them for a breadboard and this is what they gave me.
Oh, those are great perf boards.
Yes, that's what. But I realized, like, I was like, oh, this is the only kind you have. He's like, yeah, that's a breadboard. I was like, it's not a breadboard, but thank you.
Isn't it? There's like a little bit of happiness when you know more than the salesperson.
I was like, thanks. And then I was gifted this. They were like, oh, you're doing electronic stuff, right? You could use this. And I was like, I guess so.
Ooh, are those addressable?
Yes, I just was reading about them before class and they are addressable.
So then you can control the RGB color of each one of them separately, which is really cool. Then you can make like entire, like you can make all sorts of crazy stuff with addressable LEDs like that.
Yeah, and that's so I wasn't expecting to come across that. So now I have to like kind of rethink what I'm doing. I may use it, I may not use it, but I did have like another box that I left behind, but I did the whole putting it on the 9-volt battery and breaking it, which was I wish I would have recorded it, but I didn't. But that was interesting. But that's all I've got. I've got to figure out exactly what I'm doing, but it would be cool to try and make like a fake neon sign, but I don't know if that's gonna happen.
Yeah. There's a ton of cool things that you can do. I'm trying to find, oh, this is what I want. Okay. Let me share my screen briefly. With those addressable RGB sneakers, here's Firewalker LED sneakers. People have made these with LED strips like that. And there's totally shoes like this that you can buy for stupid amounts of money, but you can also make them if you want to have light on your shoes. This is completely a battery project. And if you look way zoom on Becky Stern, she's got, this is a Flora, I think, down here, and or maybe the precursor to a circuit playground. Here's the strip of LEDs. You can see even the little solder points along there. And then there's a battery pack that she stuffed in underneath the tongue of the shoe. So you can totally make your own light up shoes like this if you want to, with an addressable strip like that. There's tons, and if you're looking for interesting example projects to explore, there's tons of them. Let me send, I can totally send this link in the chat, and I'll stop my share. Yeah, Becky Stern deserves to be your hero. She's a total badass, all the way through and through. She like single-handedly built the wearables category of Adafruit early on in their platform. Very worth looking at her Instagram. Let's see. Yeah, and motorcycle repair videos. Such an interesting character. I'd really like to have a conversation with her if anybody indirectly knows her. But oh yeah, so there's tons of cool things. There's a bunch of opportunities, and that addressable RGB strip is going to be a lot of fun. I think you're gonna, it's like magical when you plug it in and turn it on, and just find like you want to find an example Arduino sketch, and then like we'll solder on some connections and just turn it on, and it'll be a magic moment when it just sort of works. So it's a really cool one. Let's see. And then Kate is showing off the stickers. Oh yeah, you made those Homer stickers, right?
Yeah, that was earlier in the week. I totally like forgot that had happened, but yeah.
Yeah, you told, here, let me share so that it gets recorded for posterity, right? That's good. That's good to do. Share my screen, and there's those, and there's look at all these fun layers. So this was, how many different colors did you have, Kate?
I don't know, 1, 2, 3,
4, 5, 6. Six different colors?
Yeah.
Right?
Yeah. Yep.
And then you sent a second one that I need to pull up to get it to work. And so in the chat somewhere, here's this, save, and then boom, it's probably right there. Oh my God, I love it with the shiny shirt. That's wonderful.
Yeah, I found a little piece in the scrap bin of that like glittery stuff, and so I was like, let's give Homer a sequin shirt. Why not?
Yeah, I'm getting a disco shirt.
The lining up, I definitely like. It takes work, and some came out better than others. I actually have one that was by itself that came out better than these, but the thing that I learned about all my work in the registration with making those QR registration was that the registration was a waste of my time, and that it went a lot better when I did it by site anyway. So
yeah, registration marks are great in theory, hard in reality, I think, for a lot of these like multi-layer sticker things.
Yeah, when I've done registration for primarily working with text, I like text and images for heat transfer. You know, I've been doing it where you're putting pieces together. It's not layers on top. And the registration I found really helpful. In this case, though, it was completely like, I even had, you can see in the other picture, I have like all the white stuff, which is like his hair and his eyes and his shirt. And it's all in one piece. And I ripped them apart and like put the hair in the top and then the eyes in here. Like even just having them as one block made it harder to do. So
yeah, totally. And that's completely what I saw with Bulbasaur last week, where you want to definitely have those pieces separated out. It's easier to place them by sight. The registration marks are great. If I think that they help if you've got something really big and wieldy, that's probably better to have them. Or text is a great example. But yeah, it's also good to say don't forget that you can do it by sight just as well. So yeah, tons of really cool things happened over the course of the week. There's a bunch of opportunity. It's very exciting to see what's going to happen next. For the projects that you take on this week, I want to again reiterate, choose things that are too easy. And from there, there's tons of really exciting projects to go after. Don't feel like you have to make something that is super exciting this week. In 1 week, a project isn't going to grow to the majesty of something that people have curated for a half of a year to put together the most iconic Instructables article, right? You got to make sure that your expectations are this is going to be quick and dirty and an easy one, and I'm going to learn from it. That's the goal this week. You will make something fun. And if you've like Kate has got a few things that came together with some nice instructions, that one's going to come together really nice. The better instructions you can find if you're following something, that's totally going to be a good way to go. There's also a lot of good space for a project this week that's just sort of electronics play, because that's a space that no one ever asks us to do. But I think as you get better at understanding how to use these pieces, learning how to play with all these electronics, that ability to play and ask questions and say, how does this work? And what if I connect it here? What's going to break it? How do I fry an LED? Those pieces may seem like weird little add-ons, but they're really important to help you extend any of these instructions that you find, so that if you want to grow beyond what you've seen before, you have the knowledge base to make that happen. So totally keep playing. Find a fun project if you don't quite know how to do play in that space, because it's not a thing we ask people to do. I'm a high school teacher, and by the time you're in high school, we basically stop asking students to play around with ideas, which is tragically sad. Let me just say, I've definitely tried to counteract that. It's tough in 2021 with a chemistry class, but it's an important thing. Let me just say that resoundingly as a teacher, play is one of the most essential things that we ignore. So find a way to do it with electronics would be totally the right move. And if it's a project to follow instructions, that's also the right move. So lots of good things. I can reach into my closet and show you all the weird electronics that I have. We have a little time if you want.
I would totally love to see the closet of electronics. I also have to add on the play note. As some of you know, I used to be at Common Ground. In fact, I'm wearing one of the shirts, which is a high school in New Haven. And they're as a high school, one of the things they would do is have the kids go out and play in the woods. And they would like make the teenagers play. And it was like the most amazing and awkward thing, because all the teenagers realized like they had no idea how to play and they'd forgotten how to play. And it was like, it was really interesting and really cool to watch. So I think more high schools need more play.
Yeah, it's so important. It's just essential. Okay. So let's see. I've got SMD components here. So these are like the little tiny solder by hand, and you wouldn't believe it things. These okay, so the dark spots on this board, those little dots on the white strips, I have soldered those onto circuit boards by hand. They're very tiny. Those are things that you can solder if you're interested in SMD. We can do soldering like that. Here's a servo. This is a servo motor with a gear put on top of it. Yeah, I got caught up. So this is a servo motor that's got some metal gearing attached. It's even like hacked apart so that there's an extension to it that's there. Here I've got a heaping pile of Arduino like pins. This is a shield for driving a 3D printer. This is a rep wrap board. So this is the shield that would sit on top of an Arduino Mega. so that you can drive 5 stepper motors. That's what each of those little red blocks are. They're stepper motor drivers that are in there. Here's, oops, now I'm typing things on my keyboard with electronics falling all over the place. Here's a Raspberry Pi. This is a Pi 3. I've got like a probably embarrassing number of these around my house. Heat shrink. So here's heat shrink in general that can be useful. This is a really nice breakout board to have. These are 2 relays. So this would be an ability to, that's way too bright. Okay, this would be 2 relays, so I could turn on and off 2 lamps if I wanted to. And all it takes is those 4 pins there. It just ties into 2 pins on an Arduino. One is for 5 volts, one's for ground, and then it's just a single pin to control connected or not on the relay. So it's as easy as driving an LED to turn on a lamp in your house with one of these relay breakout boards. So that's a super helpful thing to have if you're trying to do any of that.
I had a question in the space today or a couple of days ago that feels kind of related, and it's about the clapper. And I feel like isn't that, I don't think the clapper is run on Arduino, but isn't that basically something you could do very simply with an Arduino? It's like,
yes, the clapper is very much a ATtiny 24 project. It's not even an Arduino. It's like too simple for an Arduino. Because all it is listening for, do I hear a clap? And if yes, switch the relay from being off to being on. And if I don't hear a clap, stay the same. And as soon as I hear a clap, you switch it back. So you could totally make your own Arduino clapper if you want, 100%. All you need is a microphone that's listening for a loud spike of noise, so a clap, and then that to control a relay to change from being open to closed. That's it. That's all it would be.
Does anyone remember the clap on, clap off commercial? I wanted one so bad as a kid.
We have one in the space. That's the hysterical thing. That lamp up above where the couches are that used to move like a jellyfish. It was programmed by Arduino, and we think the Arduino board got fried, and someday it would be great to reprogram it. But because it's so high up and we didn't have an easy way to reach it, JR just put it on a clapper. So if ever you want to turn that on, clap twice underneath it and it will turn on.
That how that works? Oh my God.
That's so good. All right, we're definitely fixing that. Okay, other weird things I have. Here's just like some power bricks. At this point in life, I collect these. So if you've got random ones like this, you hold on to them. This one is 12 volts and 0.3 amps, so very low current. This one's 25 volts and 2400 amps. I have no idea what I would use this for, where it came from. That's a lot of volts. Maybe for, and that, okay, I don't know what this is for at all, actually, but it would be fun to use for 24 volts on something. This is a fun one. Here's a servo that's attached to a robot hand that was an old project that some kids did where I bought it, and so I took it with me. But here's a servo that acts as a wrist. And then this is a servo that will open or close the jaws. And so servos are really neat. And you can see the mechanism right here. Servos are neat because they move and they try and hold their position. So if you tell this that you want it to rotate, it'll rotate and then try and stay there. So servos, it feels like that's super complicated, but a well-built servo solves 90% of that problem for you. So if you want some motion, you just say, go to position 12, and it'll go there and it'll try to stay there. You can overwhelm a servo so that it doesn't stay there. But generally for like that bubble machine where it's not lifting a lot of weight, that's a really good example of using a servo well. So if you want 2 servos to build a bubble machine, I got them for you. Let's see, other weird stuff in here. This is an ESP 8266 Feather board. So this is an Arduino Feather. Let me pull it out of here just so you can see it. I do like them. I maybe didn't highlight them enough, but they're totally nice boards. And so here on the front, you can see this guy is the part that's the Wi-Fi business right up here. That's the brain and the Wi-Fi. And then on the other side of the board, it's got a USB plug. So this is how you would charge a battery, and then plugged into this really dark thing is a battery charger. So a battery plug. So you can plug in a LiPo battery in this black plug, and then you charge it over the micro USB. And then there's some circuitry that's right about here that manages all of the battery safety stuff for you. So if you want a project to be on a rechargeable battery, a Feather is absolutely the nicest way to make that happen. It handles all of the logistics of batteries are scary, and you can use a rechargeable battery without any struggle at all. And this will give you that, all of that plus Wi-Fi, because that's what the other side is. So you can have a rechargeable battery Wi-Fi thing right here that maybe would indicate with just an LED or two. So I'm thinking about home assistant stuff, Aaron. This feels like a great home assistant kind of board because you've got a battery pack. You can charge it whenever you need to and then get it connected.
I bought 5 of them, but I haven't done anything with them yet.
Yeah, no, you're gonna really enjoy it when you get it to work.
That's gonna be like the heart of all the sensors that I make, right? Like,
yeah, and
basically.
And then these have some brain to them also, so you may not even need a separate Arduino. The 8266 and then the ESP32, which is like the bigger brother, they both have their own brain power, so you may not need an extra Arduino on top of it. It is got its own processor, so it can have its own Arduino.
One of the things that I want to do, and maybe this will be like part of what I'll do next, but there's this video I found online of an individual who takes that with a PIR sensor, a humidity temp sensor, and some just like of the jumper cables that we use. I'm not sure, like I forget what the actual word for them is. And then 3D prints like a little box for it. So it's like a multi-sensor, cost them like $20 to make. Place them wherever the heck you want, and use it to detect motion and trigger a bunch of things.
Yeah, that sounds lovely. And like a PIR sensor is such a wonderful, straightforward sensor. Someone really did a lot of good engineering to make them. They send out infrared light, and then they can sense if it changes. They're the ones that are attached to garages, so they can see like if something moves nearby, they can tell. And so they're really good at that, which is totally a cool thing.
I'm wondering if that's what this is. Like if this is just a really beefy PIR sensor. I don't know if you can, it's like covered in plastic, but is there a picture of it? Yeah, so it's like just like a box with like a black dome on it.
Yeah, it probably is. The dome shape is often indicative of a PIR. Here's there's tons of different things that you can do. Like what you start to build a dumb stockpile of these things, and then you want to make a project, and you might have 80% of it if you've got a box of this stuff built up. Like here's proto shields for Arduinos. It turned out it was cheap to buy a 10 pack at some point, and so like it might have been $2 per shield or $20 for 10 or something. And I knew I would use them eventually.
These sensors are great. They were like $5. They're from Wise, which a lot of the cameras in the MakeHaven space are from the same company. And I hacked into these. It was very easy to do. They cost like $5, and I mounted them on each side of my bed. So when I get up in the middle of the night, it lights up an LED strip underneath my bed. So that way I don't like trip and fall or step on anything. And then after 30 seconds, the light shuts off. And it's like a nice like red light that's not very bright. So
where did you get those?
I just got them off their website. I'll post it in the chat, but fantastic company. They make great products and they're cheap. So
yeah, those cameras, I wanted to get one for the alarm system.
Really, really cheap stuff.
Especially the outdoor one.
Yeah, what a neat, I had no idea that, like, that's a great find when you find a product like that that's hackable, that's got a core sensor, it's got a few of the features that you want. Like that's a really good win.
Thanks, Aaron.
Yeah,
thanks for the website.
Pleasure.
Yeah, so there's tons of things. Oh, here's a big breadboard. Lila, there you go. You need a big breadboard like this. They have these posts on the side. It's a heavy board that it sits on, so it's something to anchor it to, I think.
What is the post for?
These I would say are for making connections that then you're going to go over to the board for. They're not connected to anything in particular. They're just if you wanted to have more attachment points. So there's tons of cool things. If you think of something or you're like, what is this? Or is it the same if I buy that one or this one? I'm 100% in for helping. If you're thinking about buying anything for a project, shoot me a message. If you find it's out of stock or you don't want to spend the cash, I'm happy to help you sort it out and see if there's a cheaper way, or if I have one laying around. Like, here's a bunch of connectors that Kate was looking for that I just found in my box. And so if you want some of these, Kate, I've got some for you. There's
a solenoid. Do you have any of those?
Yeah, these are female to female connectors, which again, the gendered name on wires like this should definitely be changed. But these are both, they have sockets on both ends. So if you want to attach wires into them, this is a good way to go, from like a Raspberry Pi to a breakout that already has pins on it. So these are really helpful. And at some point I must have bought a strip. I probably needed 2 out of the strip, and the strip was $1, right? Like, that's how this goes. That's the game here. So there's having pooled resources, which is what MakeHaven seems to be all about, is really helpful in getting these things to work. There's a ton of things over by the electronics space where somebody bought something exactly like this for a project where they needed 3 out of 40. And then the rest of them are just laying there. So there's tons of stuff like this. If you look around, search in the back, find what's going on. We're kind of working on maybe making a list for the store of like things that would have a charge to them. But for right now, I'm just give you this stuff out of my pack.
Corey, last night we were talking about like making a solenoid from scratch. Do you have any examples of that?
I don't here. I would need to dig around and find some, but it's just
okay.
a solenoid is just a coil of wire around a core. And I can probably find a good example of solenoids by hand. Let's see if we can find solenoids curled up by hand. And so solenoids on McMaster-Carr, there's going to be a ton of, nope, those are not going to be by hand at all. There's tons of interesting ways that you can actuate movement. And one of them that's fascinating is a solenoid valve where you can get, it's just a little coil of wire that acts like an electromagnet that will push back and forth. And now there we go. Images, and let me share my screen where you can do this. So if we hit share, these are all solenoids. And so a solenoid is just a coil of wire, but it turns out that it's also how you make an electromagnet. And so here's one that's kind of made by hand looking, or here's one that's definitely made by hand. These are a great like physics teacher example where you put current in on this side and it makes it into a magnetic field that goes in one direction. And that seems like a weird, quirky thing to have this sort of a setup. There's some good math you can do with all of these. AP Physics 2 loves them. However, what they're useful for is exactly this, where they're like a little valve where you flip a switch and then a plunger moves. And so solenoid valves, you'll have this coil of wire that moves something. And so I want to find a good example of one of these. Solenoid Doorbell. Let's see if I can do. And so a solenoid doorbell is going to do something like this. So in here, you've got a coil of wire and then this little metal rod that is going to be pulled by this coil, and then it'll hit a bell. Or like, here's one where you can see the winding and an Energizer battery. So in here, this is a coil of wire. You can see that red enamel coated wire. It's just wound up and it's going to pull this thing in, and it may hit something over here. There's a good, I don't know why this is what's popping into my mind, but there's an OK Go music video where they do the big Rube Goldberg machine. And at some point they use solenoids to play music on cups of water. And so that's where my head went just now. But these are just coils of wire, these solenoid coils where you can attract and repel things off of there. Let's see. I think the song was This Too Shall Pass. Let me stop my share and hop back over here. Yeah. Yep. So there's tons of examples. I'll find that little snippet of the video and show you solenoids in action. But it'll take a little digging to find that like 3 seconds of the song. but it's totally there. So you can see lots of examples of different solenoids. They're fun. When we get to outputs, we're definitely going to include them. We're going to have, so there's a few things to think about, like broader picture moving forward. The next couple of weeks are going to be about 3D design and 3D printing. And then we're going to switch over to do some other things, but eventually we'll cycle back to circuits, and we'll do a whole week on just inputs and a whole week on just outputs. And so right now it's sort of hodgepodge, whatever you find, whatever you're interested in, you explore those. But then we'll sort of go through a list of these are all of the inputs and outputs that are even plausible for a starter project. And so then they start to become more like a menu of, oh, I'd really like to have this and I'd like to have that. Like I can imagine Aaron's PIR sensor and some addressable LED strips from Anna's stuff. And how cool if you got up in the middle of the night and instead of just a red light, you get a rainbow light, right? So you change your inputs and outputs and you get different combos that you can play around with.
Follow the rainbow to the bathroom. Right?
That's exactly right.
Sure, why not?
So there's tons of cool options. So that's sort of where we're headed long term as we think about how do we deal with all these things. And a big part of that is going to be how do you add motion? Because there's tons of things in MakeHaven that are possible because we have electronics that can control movement. And so the vinyl cutter, the laser cutter, the 3D printers, the CNCs, all of those machines are based around the fact that you have some sort of a real-time system, a microcontroller or something like it that's able to do movements. And so learning how to manage movements with microcontrollers will be a big part of it. So there's tons of cool things. There's a lot of exciting, and the whole video is totally worth watching, Kate. It's a good music video. It was engineered by NASA interns, I think, over the course of a week, and OKGo acted as their directors. Good backstory. There's like there's hours and hours of backstory on that music video. But yeah, I think that's probably good for a wrap